going to do a quick introduction about him. I mean, he's been writing code as a developer for over 10 years, and 2 years of which he was a technical coach. I think that's the less interesting part. The more interesting bit is that he's actually a qualified nature guide. Go figure. It's awesome. Yeah, and the other thing that he does in his part-time is he does lecturing to postgraduate students at VET. And so over to you, Joshua.
Thanks, Mandla. Does it sound good? Hi, everybody. Thanks for coming to hear me speak. I know that there are quite a lot of options, the workshop and other talks. I really appreciate you coming to listen to me. Thank you. I'm Joshua. You may know my face and my voice may be familiar to you as well. So I work at InReality. I'm an associate at InReality. Work as a developer coach, do training and development as well. And as Mandla mentioned, I lecture part-time for the JCSE at WITS at a postgrad level. First thing, I'm not checking email and WhatsApp. I'm going to control my slides on my tablet. I can do things like put a virtual laser pointer on the screen. So don't get distracted by this. I'm on Twitter, so my handle is @JoshRLewis. I'd love to continue the conversation afterwards with you guys if you want to continue it. And I work best in interaction mode, so there are quite a few of us, but I have a small enough audience. If you guys have any questions or you don't understand something, please feel free to stop me, and we can chat about it quickly. I might say, let's talk about it at the end, or I'll answer your question later on, but please feel free, just put up your hands. I don't mind being interrupted. One last thing before I start, you'll notice that on this door there's 3 stickies. There's a happy sticky face. So I put up this stickies. I want to get feedback from you guys. So on this table there's some pens and markers and sticky notes. Please leave me some feedback kind of as on your way out. I want to improve the talk, so please be as specific as you can. The idea is there's 3 faces. One is a smiling face. That was awesome, very valuable. The middle ones, they're kind of, I'm not really convinced. And the bottom one is, I'm never getting that half an hour of my life back. What a waste of time. So the idea is write your feedback on a sticky note, try to be specific, and then just place it in next to the appropriate sticky. Cool. Who of you guys went to Neil Ford's talk this morning? Just a quick show of hands. Okay, good number. Next question for you guys. Who has worked or continues to work with code on some reoccurring basis, so actually like hands-on with code? Okay, cool. So there's a bit of a mix. Cool. So the kind of idea of this talk is around the evolution of software systems, but specifically around the idea of technical debt. Okay, so technical debt. Some of you have heard of it. Some of you may have not. But the reason why this talk is interesting for me is non-technical people don't understand technical debt, right? And one of the reasons they don't understand technical debt is I don't think developers understand it well enough to try and explain it to them. So, we often have meetings with product owners or business analysts, and we kind of in a sprint planning, for example, and they say, no, we need some time to refactor, or the code's broken, right? Or the system needs to be rewritten. Those kinds of things sound familiar to anyone? Cool, and like product owners go like, no time to refactor, why do you want to rewrite it? So hopefully after the end of this talk, you'll have some tools, some models, and maybe some vocabulary that will help you, if you're non-technical, to understand what we mean by technical debt, by a certain type of technical debt. And if you're a developer or an analyst or a tester, hopefully you'll be able to explain it a little bit easier. That's at least my intent. I'm not going to talk about all forms of technical debt, so there's no universally accepted definition of what technical debt is, first of all. So I'm just going to speak about one kind of technical debt today. Yeah. So who recognizes this photo? Guys in the back, feel free to stand up if you need to, or I can also, Actually, I prefer downstairs if that's okay with you guys. So this is a photo of the pedestrian bridge collapse over the M1 near Grayson off-ramp, which I think happened last year, if I'm not mistaken. Sometimes these things get away from me, but I remember it was last year. Okay, you guys remember the story? So if you're on the highway or anywhere in Sandton that day, bad day for traffic, right? Who here commutes into Sandton and out of Sandton every day? A lot of fun, right? So even though every day there isn't a bridge collapse, commuting into and out of Sandton every day is a real pain. Like traffic in Sandton is a bit of a disaster at the moment, right? Especially if you live in Pretoria, Centurion, it's just a long drive. I live about 5 kilometers from Sandton, from the CBD. Depending on the time I leave, it can take me about an hour or so to get there. So it's bad. So how did it get like this? How did it get like this? Like, it's not a cool way to live, right? So how did we end up in this situation? Sorry, say again? Bad planning. Well, maybe. Say again? Development?
Yeah, so maybe they didn't predict how big the system would be in the next years.
Cool.
They didn't expect over, basically the growth of Sandton was this district, basically with a lot of big corporates coming into Sandton. So you didn't take into consideration that as well, which brought that added traffic flow and pedestrian flow and everything into Sandton.
Well, so why do you guys decide, like, that's the talk? No, I'm kidding. I agree with everything so far. Roy?
Victoria doesn't have any jobs.
Victoria doesn't have any jobs. So, I'd like to talk about the story of Sandton a little bit. Okay, so this is a photo of the site of Sandton City and the Sandton Town Civic Offices in 1961 when they were born. Okay, so Sandton CBD is only about 50, 60 years old, right? Not that old when you think of cities. So when the Sandton CBD was originally planned and laid out and designed, there were certain assumptions that were made, right? So how many people are going to have to be accommodated every day in this area? And based on that, you know, how much capacity do we need for cars going in and out? How much electricity supply does it need to be? Water, sewage, all of those kinds of things, right? So you guys mentioned quite a lot of it in terms of how we got there, and it's when it was planned, there were certain assumptions that were made, and those assumptions informed the layout and the design of the system. Cool? Does that make sense? And perhaps one assumption they made was, well, we don't need any kind of rail public transportation coming in here. Okay? Whether they made it explicitly or not, or deliberately or not, doesn't really matter, but the point is that decision was made. Cool. Then, mid-90s, Joburg CBD starts to decline. Okay, and guess what happens? Bit of decentralization, but the way I see it is a lot of businesses up and left Joburg CBD, and they moved to Sandton CBD, right? Makes sense. So now we've got this massive influx of people. Cool? So the fall of the Joburg CBD, the rise of Sandton CBD. And just as a very quick aside, there's a lot of urban renewal happening. Braamfontein, Chimalachong precinct, so have a look at what's going on there, very exciting stuff. So we have this rise of the Sandton CBD, okay? Now, I'm not 100% sure of hard facts and figures, but there are thousands and thousands of people coming into Sandton CBD every day, and the same people leaving every day, right? And a lot of us have felt that pain. We feel it daily, right? And it's a real pain, like it's a disaster. It takes a very long time to get in, very long time to get out, lots of money wasted, lots of effects on the environment, etc., etc., etc. And the point is that there are a lot more people being accommodated in this piece of land than was originally planned for. Okay? And it's not only the CBD that can't handle this people, it's the surrounding areas, right? Because people need to get in and out, they need to traverse through the surrounding areas, and it's not really working that well. But what's important to remember is that this is a 40 to 50 year journey, right? From when this part of Johannesburg, well, originally wasn't part of Johannesburg, but when this part of the country was planned, right, to now, it's a good 40, 50, 60 years. And what's important to remember is that the original assumptions that those town planners made have held for 40 to 50 to 60 years, right? It's taken us this long to say, listen, guys, this part of boiling, if we're frogs, this part of boiling water is now starting to get a little bit hot. Maybe we should make a plan to jump out. And that's an important thing to remember, that we're feeling pain now, but it's taken us a very long time for that pain to become so acute. And the idea I want to kind of get across is that the design of the system was right until it was no longer right. Right? Working, and not working. Cool? And we could probably chart that out if we really tried to. So how are we trying to solve the problem? Gautrain, right? E-tolls, favorite topic. Gauteng Freeway Improvement Project. Rea Vaya. Initiatives like no cars in Sandton CBD for a week, which didn't go down so well, just by the way. So we're trying to mitigate this problem. Cool. Now, I want to kind of take you guys on a journey around, well, how does this pan out with software systems? So think about this journey that Sandton has been on and this pain that you feel every day, and try and transcribe that same journey in software. Okay, so we start out, we're building a new system, we've got a problem that we're trying to solve. Not really so important what the problem is, and we say, we think that this particular model is going to be a really good way to solve this problem, right? In design a system, we can structure it with these parts interacting with each other, then it's going to be a good way to solve the system. Okay, it's elegant, it's simple, it's beautiful, right? It's our baby. And we've birthed this baby, and it's pristine, and it's just too beautiful to look at, right? And we love it, and it makes sense. Simple to understand, easy to reason about, easy to change, right? I can make a change over here, and I can predict what effect that change is going to have. Does that make sense? But then our product owner comes along and says, listen, we need to make a change. Our system now needs to do this. And we think, our model didn't really originally cater for it, but we'll make a compromise. So even though our rules governing our structure in the past said things should only be collected like this, now we're going to compromise and we're going to connect nodes 4 and 3 to node 1 as well as the immediate neighbors. Okay, a small compromise. Right? Makes us feel a little bit uncomfortable, feel a little bit dirty, right? Goes against some of the things that have been drummed into our heads for years and years and years in our training and our experience as professionals. But we kind of think, listen, it's not so bad, right? I mean, we can still reason about it, we can still understand the model, we can still reason about it, we can still predict change. So even though it's a compromise, we'll live with it, right? Does that sound familiar? Cool. But eventually what happens is the compromises build up and build up and build up, and especially for non-trivial systems, for example, this graph with only 12 nodes, you start building a big ball of mud, right? So Neil, in his presentation this morning, had a very similar diagram, that red big ball of mud with classes on the outside with the connections, right? Very complicated, very difficult to understand, very difficult to reason about, very difficult to change. And the reason it's very difficult to change is we cannot predict the effects of changing any one node. Because there's so much interconnectedness and couplings, we lose that ability to predict the effects of change. Okay? And what happens is because it's so difficult to make these changes, right, it takes us longer to get changes out. And when we do, there's more bugs. Anyone experienced that? Right? As you go along, it takes longer and there's more bugs and there's more risk. And as you go on, it takes longer and there's more bugs. Right? Not a cool situation, really. And at the extreme end, and unfortunately it's not that extreme, we hear about it quite frequently, developers want to rewrite the system. Right? It becomes so difficult to work with this complicated system, right, that we say, listen, we're starting to reach the point where we will gain more by rewriting than by continually trying to tame this beast. Cool? Unfortunate situation, but it's very real. So this is what I've come to learn about the evolution of software systems and technical debts. Okay? And even though I'm talking about software, think Santon. Because it's the exact same concepts and it's the exact same journey. Okay? There's no difference. The only difference is Santon is real, and as Jacques mentioned, it's difficult to refactor concrete, right? It's difficult to refactor code, but it's not as difficult. So bear in mind this model as we go along. So expect your first model to be wrong. Okay? So 60 years ago when they were planning Santon, they had a model. We can pretty confidently say now that that model is wrong. Right? Does that make sense? Now, economically, if we look at this, we could have said, well, let's not build Santon until we've kind of figured everything out. Right? Well, that doesn't make sense. So economically, we have to make some assumptions in creating our first solution. Right? We have to. There's no way around it. We have to make assumptions. Now, technical debt was invented as a way to describe these contexts in an economic context to non-technical people. Right? Technical debt is an enabler of product and an enabler of business. Okay, but it needs to be used correctly. And the reason why it works as an economical model is often our very first solution, and if you were in Henrik's talk yesterday, hopefully you'll have got some of these ideas, but our very first solution only needs to be just good enough to learn something. It doesn't need to be the best solution, whatever that may mean. It just needs to be good enough for us to learn something. Okay, it's something like Henrik was talking about bets. Right? We've got a bet. Is that bet going to pay off or not? How do we learn that quickly? Right? So our first solution we use to play out the bet. And because there's always going to be assumptions, it means our first model is always going to be wrong. Right? There will always be unforeseen changes. There will always be things that we assume to be true in the beginning that at some point will no longer become true, or that we assume to be false and become true. There will always be assumptions that will be proven to be invalid with time. Right? That means there's no perfect model. Right? Not only does it mean there's no perfect model, it means that there's no right model. Right model. And the reason is that every design, every model is right until it's proven wrong. Right? My thesis is that for any design you show me, I can throw out a change that will break that model. Right? There's no model which can cater for any and all changes. And if there was, it would most likely be economically unfeasible to pursue it in any case. Okay? So there's no right model. Your first model is definitely not right, but there is no right model, ever. Okay? I've been talking a lot about assumptions that can become invalidated. Now, what's important to note is that there's two sources or two ways in which assumptions can be invalidated. Number one, the problem changes. Right? So Santon was designed for a certain number of people. It's now got maybe 10 times that number of people. The problem has fundamentally changed. Right? But there's a second source. And the second source is that we learn about the problem space as we go along. And we also learn about the solution space as we go along. Right? So one of the things about technical debt is, well, about software design is, we should have designed it this way. Right? Now that's learning about the problem space and learning about the solution space. So important that assumptions can be shown to be wrong from two places, the problem changing and from learning. Okay, so where do we go from here? We don't want to rewrite because potentially catastrophic business consequences for that. But on the other hand, we also don't want to be continually remodeling our entire system for every small compromise, because that just it takes too long, and there's so much change coming in all the time that we'll fall behind very quickly and we'll never catch up. Okay, so the first thing is make considered compromises. Okay, be aware of what the compromise is. Talk about it in your team. Say, listen, our model doesn't cater for this. We can solve it this way. Cool, let's solve it that way. What are the risks? How are we subverting the model? How are we breaking it? Okay, cool, eyes open from the beginning. We know the consequences, let's do it. And the reason why we say let's do it is because there's an economic equation behind the let's do it. Right, we have to make the compromise in order to ship the product. Okay? And if you've heard of Martin Fowler's technical debt quadrant, it's a nice model for thinking about considered compromises. The next thing is, the part of considered compromises, be aware of a critical mass or a tipping point. Right? So we compromise, at which point you need to say, hold on, no more compromise, because the consequences of this compromise in this area of the system's going to have a very large and lasting impact. Let's rather take some time out and remodel. Okay? And be conscious and deliberate about where on that spectrum you want to be. On the one hand, we wait until we fall off the cliff, the rewrite. On the other hand, we move so slowly that we never actually get anywhere. Right? So decide where you want to be and be sensitive to critical mass and tipping points. Now, the next thing about considered compromises, know how to spot compromises retrospectively, and probably keep a list when you do make them, keep a list of the ones that you're making. So one, that you remember them, and two, that when you've decided to go back and remodel, right, you know where to look. But also be aware of to say, listen, we didn't see it at the time, but this was a compromise. We didn't see it at the time, but this is a compromise. Okay, so I don't think keeping a list is enough. Either one is not enough on its own. One of the heuristics, for example, about knowing about a tipping point is the rule of three. So when you've got three of something, for example, three if statements or a case statement with three branches, that's potentially a rule for a heuristic saying maybe you should refactor this. If you've got three kind of similar classes, maybe you've got a candidate for an abstraction. But don't do it if there are only three, right? Rule of three. Poorly named because it's a heuristic, not a rule. Next thing is knowing how to repair compromises. Okay, cool. So this model is compromised in this way. How do we fix it, right? And there your friends are refactoring and design patterns, right? But most importantly, refactoring. How do I change this code? How do I take this code, remodel it without affecting the way the overall system behaves? Neil Ford spoke about adaptive design. Make your technical designs adaptive to change. Right? We know up front we're never going to have the right model. So how can we design it so that it's adaptive to changes? Okay. And there's some other things that I think are really, really important that I want to end off with. Okay. So developers have a bad habit of saying the code is broken, we need to fix it, we need to refactor. Right? Who said that or heard that? Code is broken or the system is broken. Right? Nothing's broken. Right? Santon wasn't broken. Santon isn't broken. The design is based on assumptions which are now invalid. Right? So it's not broken, it's not wrong. It's just we've learned about the world, we've learned the problem has changed, or we've learned more about the problem and the solution. Okay? Oh, and just by the way, if you're not ever having to go through this process, means nobody's interested in your code, which means what's the point? Because no one cares about your code, right? So only living systems change, right? Maybe it'll be a bit prejudicial, but I'm not sure if anybody worries about Randfontein traffic. Like, is anybody really worried about getting in and out of Randfontein? And I've just picked Randfontein top of my head, right? It's like, yeah, that model is fine. And the thing is, no one could have seen this coming. We couldn't predict these changes. We couldn't predict these learnings. So it's not broken or wrong. The other thing is that, and developers are particularly guilty of this, looking at some code and think, geez, how could this person have thought this was a good idea? Right? I know I've said it. Most of the time, the person who thought it was a good idea was me, a couple of days, weeks, or months ago. Right? And the only thing that's changed is either the problem has changed or my learning has changed. Right? But fundamentally, nobody gets up in the morning and says, I'm gonna write crap code today. I'm going to design a crappy model, right? It's always done with the best of intentions, with the information available at the time, right? So developers are not stupid, developers are not bad, developers are not evil, developers are not incompetent, right? And by the way, this isn't about developers, this is about the whole team, because the whole team is hopefully disassembling the problem and assembling a solution, right? So blaming developers, not a good practice. And the last thing I want to add is, who has a mortgage on their house? Jeez, those of you who don't have your hands up, I really envy you, right? But the point is, what happens if you don't pay back your loan? The bank comes and repossesses your house, right? Debt is an obligation. Technical debt is an obligation. Meet your obligations. Pay down that debt. Because otherwise, you get closer and closer to that cliff. And the longer you leave it, the more the interest compounds, and the harder it is to pay it back. So meet your obligations. Guys, if we've got time, I'd love to take questions, but thank you very much for the opportunity, and thank you for listening.
Okay, at this point, we'll take questions. I think we can take 2 or 3 questions.
Sorry, also, we'll be at the Fishbowl. Yes. Is it 2:30, Jacques?
2:30.
I think
so
at
you can also
2:30
catch
I'll
up with him.
Be at the Fishbowl in Derbytree downstairs.
Any question? Okay.
Sorry,
there's a mic coming.
With your adaptive design, try to keep your designs able to adapt quickly. Can that not lead to a lot more complication when you try to make things so general that they can accept anything and then suddenly...
So I'm saying the opposite of that.
Okay.
And maybe, and I should have been clearer on that, I apologize. So don't make it general that it can accept anything. Make it simple, so simple and concrete. So solve today's problems today, don't solve tomorrow's problems today. But that doesn't mean necessarily going about it in a stupid way, right, or a bad way. But definitely make it as non-general as possible, because the thing that trips us up is making things general. And that's when things that get coupled to things they shouldn't be, poor abstractions, leaky abstractions, that primordial abstraction ooze that Neil Ford was talking about, that comes from premature abstraction, premature generalization. And that's where things like the rule of 3 heuristic come into play. Like you want to make that abstraction as late as possible, and you need to know, for example, that, hey, it looks like this part of the system is going to be changing more in the future because we've already had to make 3 changes to it, or 2 changes to it, right? Before then, you just don't have enough evidence to make that prediction. And making a generalization before you've got proof of it is very, very problematic. Source of a lot of complexity.
We can take one more question.
How's it? Do you have any advice on an engagement model? Because I think part of what the learning is eventually finding out what it is you didn't know. Is there like a model for like just trying to get those insights out of whatever particular solution you're trying to get out there?
so I don't really have a framework for having that conversation. I think the best advice I can offer is two things. One, in terms of a technology team, i.e. people who are more familiar with the code, be very eyes open and upfront about the model. What is the model? What are the compromises we're making? What are the consequences of those compromises? When are we reaching a tipping point, right? And when you're talking with product owners, analysts, product managers, certain language I wouldn't use, so broken, wrong, fix, right? That's not broken, you don't need to fix it. So listen, and the whole idea of the Santon story is use that story, right? So on Monday or tomorrow you can go, hey, listen, product owner, I heard this really cool story at Agile Africa, right? Think of what happened to Santon. And that's kind of what's happened with our code bases. And you could even retrospectively say, well, listen, we made this assumption over here. This was our design. And you could probably go through your code base and say, oh, this is a compromise. And, oh, yeah, remember we made it because of that feature. You could even do things like, so Asla mentioned yesterday, the book, Your Code is a Crime Scene. You could, for example, link your Git logs to your Jira, for example, and say, oh, yeah, this code changed. We compromised the model because of that feature. Now you can tell your product owner, you may not be able to necessarily draw it out. So that's one of the problems I had for this talk is it's quite not so easy always to draw a model, right? But fundamentally, I think developers have a model in their head. By the way, just because it was difficult for me doesn't mean it was difficult for you, right? But we had a model. It was awesome. We had to make a few compromises to get product out the door, and it's no longer awesome. And you know what? Now you know why it's taking us so long to get stuff out and why we can't predict the side effects, and that's why they're bugs.
Okay. Yeah. I mean, if you have further questions, like you said, you can meet him at 2:30 in the fishbowl,
Yep.
just to discuss more. So thank you, Joshua. Good talk.
Thank you,
And
guys.
Thanks, everyone.
Please don't forget the feedback stickies on your way out.